Hello,
Can
sir.
you hear me?
Yes, sir. Thank you so much for joining. And I'm delighted that you have joined us, sir. We will be starting shortly at 3 p.m.
Okay. I can't start my video, so that's fine. Host has
Yes, sir,
stopped.
you can.
No, the host has stopped it.
Yes, sir. I'll make sure for it. So be online just a minute.
I wanted to just check the light and other things.
Yeah, sir. Definitely.
Yeah,
Okay. So you can check it now.
yeah, I can. I think the lighting is bad. So let me see if I can move. It's better now.
Yes, sir.
And let me check. This is fine. Can you hear me?
Yes, sir. I can hear you. That's fine.
Yeah, I'm sharing my screen just to check. Okay.
Okay, sir.
Share. Can you see this?
Yeah, that's visible.
Okay, let me present. I don't have many slides. I just have 4 or 5 slides.
Okay, that's totally fine.
Yeah, because I think a lot of gyan available any which ways, and I don't want it to be long.
Yes, sir, definitely. We will look into Q&A section more.
Yeah, yeah. People have a lot of questions. They don't want to listen to
Mhm.
one-way communication. Okay, now I'm gonna stop sharing.
Hello, everyone. It's great to see you guys joining early. Stay tuned. We will be starting shortly. Okay, so welcome everyone to another session of the DataHour series. We will start the session at 3 p.m. IST, which is just 3 to 5 minutes from the current time. And soon I will be sharing two polls. So make sure everyone to participate in that. Also be prepared with your questions because we will be doing more Q&A in today's DataHour. And Sachin, so we will be starting shortly. Let few more people join us.
Sure.
So I'm shooting two polls here. First one is regarding your location, and the other one is to know your experience level in this field, which I expect everyone to engage with. Let's wait for 2 more minutes. People are joining us. Okay, so I think we are good to go now. So everyone, good morning, good afternoon, and good evening, respective of your locations you are joining us. Welcome to another session in the Data Hour series. We are thrilled that you all have joined us for an interactive learning session. I, Raksha Nagaria, part of the data science team at Analytics Vidhya, will be the moderator for this session. And for those who have joined us for the first time, a brief introduction about the Data Hour sessions. With the intent to make learning data science more engaging to the community, we began with our new initiative, Data Hour. Data Hour is a series of webinars by top industry experts where they teach and democratize data science knowledge. Now, on to our session today, which is real world applications of data science. A brief introduction about this. In this data hour, Sachin is going to cover following topics, which is mental models of thinking about data. Why is the cloud required for data science? Cloud platforms and tools, industry applications, and much more. He's also going to answer all your data science related doubts. So be prepared with your questions. And before we kick things off and I introduce the session presenter, a quick recap of the housekeeping items. We are recording the session and we will make the recording available in a few days on our YouTube channel. Please use the Q&A section for asking any questions you might have during the session. As the data hour progresses towards the end, we will do our best to answer them. Also, we will share a feedback poll towards the end of the session, which I request everyone to participate in. Now, on to our speaker in this session of Data Hour, we have Sachin Pai with us. Sachin has 15 plus years of experience in cloud and data science. Currently, Sachin is Director of Cloud Scale Analytics and AI at Microsoft. Prior to joining Microsoft, he was lead big data and analytics at Amazon Web Services. He also has been associated with companies like Oracle, Gartner, and HP. Over to you, Sachin. So the virtual stage is all yours.
Thank you, Raksha. Appreciate this opportunity and glad to see so many people across the globe joining in. I'm a bit under the weather, so bear with me a little bit. I'll just give a quick introduction over and about what Raksha has spoken about. I work with Microsoft currently, and I look at analytics and AI as a subsection within the Azure data portfolio, and work predominantly with the financial services sector in India. Uh, Over and above that, I also work with a few startups where I am an advisor and a mentor to them, and I sort of help them on their go-to-market growth hackings over and about technology. Right. Uh, I don't have a very long presentation today. I don't agree or believe that a monologue from my end will do justice in terms of your time and this 1 hour that we have. So I had specifically requested the analytics with their team that I'm going to keep a very short presentation. I'm just going to talk about how to think about data science, right? And this is typically because I meet a lot of people, especially young people, who come and ask me these questions around data science, and I see that the model of thinking can be improved, and there is a better way to sort of think through data science as a subject. Over and above that, I would request you to sort of ask as many questions as you can, and I think Raksha has called it out, right? So I'll just get started. I'll share my screen. I have a very short presentation. Just a second. Raksha, can you confirm if the screen is visible?
Yeah, that's visible.
Yeah, perfect. So I am not using the word data science in my first deck because I think there's a lot of applications to data itself, right? In many ways, and the ability to do that is the science around it, right? So we'll just talk through in terms of how to think about it. So I'm sorry, just give me a second. Some issue with. Okay, cool. So when we talk about data, you see organizations, and when I say organizations, I mean any organization, which it can be a large enterprise, it can be a small, medium business, or it can be a startup for that matter, right? Always think about it in terms of how can I deliver intelligence with the data that I collect from my customers, from my transactions, from my interactions, and so on and so forth, right? And the data comes in from many sources, right? In terms of applications that you have built, in terms of data you collect from the customers, there is clickstream data, and so on and so forth. So the idea is to figure out how this data that we collect can be used to improve multiple facets of reaching out to the customer or reaching out to different geographies and so on and so forth, right? And while we do that, we also sort of think about areas of how because we are collecting all this data, we think about how we can get our employees, right, to sort of use data and without having to sort of do a lot of engineering around this, right? So what we have seen over the last 3-4 years is there is a huge or a massive movement towards citizen data scientists. I'm not sure how many of you on the call are actually into data science or looking to get into data science. But I think what has happened over a period of time with cloud and especially a lot of development in cloud and open source server systems and services, we have seen that there is the ease of working with data or the ease of using data science has become far more easier, right? And that is where we sort of have to now start applying or thinking about how do we just sort of leapfrog, or how do we, go to the next level on this? Some challenge with the earlier slide, but basically that slide spoke about, the slide basically speaks about, what is the average percentage of organizations that are looking to deploy AI or machine learning or data analytics in their organization. The global average on that slide, I'm not sure that there's some technical issue due to which the slide is not coming up, but I just put in some numbers. The global average is around 87% of the organizations, right, are looking at data and trying to apply some sort of framework around it into to understand it better, right? And when I talk to my customers, I generally say that every customer wants to do data science, or everyone wants to do machine learning or AI, and I think it's such a vast space. What I've tried to do, and that is what I'm going to talk about a lot more in one slide, is try to break it down into very simple mental models, right? And this is applicable not to an organization or not to a type of an organization. It is not applicable for manufacturing, or it is not just applicable for financial services. It is applicable to every single industry that exists on this planet, right? And that's how simply I have sort of broken it down. And so this also is applicable to aspirers of data science, or people who are aspiring to get into it, or even are into this field but are looking to figure out how how can I sort of progress in this vast space, right? And it's a very complex space, it's a vast space. So how do I progress, right? So, and irrespective of where you work, right? You may be an engineer in a fintech, or you may be an engineer in a data science engineer in a bank, or a manufacturing organization, right? Or an e-commerce organization. It doesn't matter, right? And that is how I have sort of filtered it down. So let me just get to it. And so what I've done, what I generally tell my customers, or even folks, right, like who are getting into this space, is, the entire data space can be broken down into two important things, right? That you have to just think of it from two perspectives. The first perspective is business, right? And you have to start with business first, and then you move on to, the platforms or frameworks, or whether you want to do it on AWS or Azure or anywhere, it doesn't matter, right? And that is agnostic. But you start with the business that you are in, whichever industry that you're in. And while I'm talking, you can do this exercise for yourself, right? So you may be in a telco company, and you can start thinking about where you're working, and you may not even be a data science data science engineer or somebody into data science. You may be into a business function, but you may want to think about it from this perspective. So every organization, irrespective of who you are, thinks about only four key things. There are only four key things that a business needs to work upon, right? Very simple. One is revenue, right? Every business on this planet is in here for revenue. And revenue means, how do I generate more top line for my organization? You may be a $10 million yearly organization. You may be thinking about, how do I become $100 million organization? You may be $1 billion organization, and you may be thinking, how do I become $100 billion, or $100 billion wanting to become $1 trillion organization, right? So every organization in the world thinks about revenue, right? And as a data science engineer, or even as a business guy, forget about data science engineers, as a business guy, right? You have to think, wherever you want to apply this, right? Or however you want to practice this, or you are maybe trying to learn something new. Think about it as that, if I want to go into an X business, how do I think about increasing revenue for that organization? Right? And then work backwards and say, okay, so what data can help me sort of achieve this? And then take another step back and say, how do I collect this data? And then take another step back and say, what are the tools that I can use to analyze it, right? And then take another step back and say, how do I, what are the insights that I need to get from this bunch of information, right? Right? Because data collection is ample and available everywhere. The idea is to figure out the insight from the loads of information that is available currently, right? So the first way to think about it is revenue. Now, if you're generating revenue, you need to also think about profitability, right? So you can't be a revenue generating organization operating at loss for a long period of time, right? Although some startups may defy my argument here, but I don't think they do have a very long runway. At some point in time, maybe even 15 years down the line, every organization thinks about profitability. And how do you think about profitability? And when you think about profitability, you can think about, like, what are the different levers using data I can sort of figure out, to reduce my expenses or reduce my costs around these areas, right? Very simple thoughts, right? So when I say CAC, so I just clarified, it means customer acquisition cost, right? So if you can acquire more customers at a lower cost, you automatically are able to improve your profitability, right? If you are lowering the fraud within the organization, right, whether for financial services or even within your manufacturing or retail, right? So fraud is ample and prevalent, and how do you sort of reduce it to sort of, which will sort of impact your bottom lines, right? CASA growth is a sort of a banking term. So any bank sort of who would want to improve their profitability would want better growth in CASA. Right. And the third most important thing is customer experience, right? No organization has been able to survive with a poor customer experience. And we also think about customer experience in multiple ways, right? How do I open multiple channels or modes of engagement with the customer, right? Now think about it, as I said, I do this exercise. So if you're a telco, what kind of channels do I reach out to my customer with, right? Can I have an app? Can I have a store location, and so on and so forth, right? How good is my customer experience when I get onto the app, right? So that is another. So banks sort of, if you think of, if you're in the banking space and you think about it from a bank, a lot of banks, especially in India, if you've seen, have very poor UIs or very poor interfaces for customer interaction, right? And UPI came and just solved it in 1 second. So if you had to transfer 2,000 rupees to a friend, right? So you owed him for a dinner maybe, and you had to transfer that money. Earlier, you had to go to net banking, add him as a payee, blah, 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 do the steps, get verified. And then after a point in time when the gestation period is over, you would transfer 2,000 rupees. Imagine the effort to do it for 2,000 bucks. And now UPI came in, and UPI is an Indian term. It's Unified Payment Interface, which lets you sort of transfer money via your app or a mobile phone very quickly, right? Instantaneous. I saw a lot of folks joining in from Africa. So it is sort of equivalent of the M-Pesa that you have in Africa, right? And it is absolutely hassle-free. So in today's world, if you have to transfer 2,000 rupees to a friend, you just scan his QR code or get his UPI ID or just put his mobile phone number and done. Like in a minute, he has it, right? And once you realize that this experience is available, you sort of moved away from carrying cash, or moved away from cash, because it didn't make sense, right? You got a better customer experience by using UPI and better safety, for example, right? You didn't have to carry cash. Everything was in your phone, and so on and so forth, right? It gave you a very differentiated experience in terms of just on a very simple transaction of money transfer, right? And then now you think about this from a mobile phone app, right? Like which sort of helps you transfer, like an Amazon Pay or a Google Pay or a Phone Pay or whatever. Now you think about it, what would these guys sort of do, right? One is they will give you a very seamless experience, like 1, 2, 3, you're done. Like in a minute, you transfer the money. The other way they would think about it is like, how do I collect this data from this person, right? Like he's been transferring 2,000 bucks every month to an ex person. Why is he doing it? So they'll put a tab below and say that, why are you doing this? So you may say grocery, you may say milk, whatever, whatever the transfer is for. And then they would sort of try and figure out, okay, this person spends X amount of money for doing this. And then you'll see a relevant ad around it. You'll see that, okay, if you go for this milk subscription service and not your local local store, this is how we will sort of make it better for you. And we'll give you a discount and so on. And then you sort of get hooked onto the subscription service. So they used your data, give you a superior customer experience to start with, used your data, and then they sort of applied it to a real world use case, which is sort of promote another brand, right? So what I generally tell everyone is that customer experience drives profitability and customer experience drives revenue, correct? With a poor customer experience, the top two pillars are impossible to do, right? So now coming back to just a small quick recap, right? So whenever you're thinking about data science, whether as an applicant, as an aspirer, as a practitioner, right? You think about, when you go to your job, you think about, okay, what are the 5 things I need to do to sort of use this data, and how can it help? Make 3 buckets and say, how can it help me increase revenue? How can it help me increase profitability? How can it help me improve my customer experience, right? And when you do all of that, the last pillar is risk and governance, right? So risk and governance is sort of, I think, the most important pillar, right? It is sort of a circle which covers all the 3: revenue, profitability, and customer experience. It does that because I think any data, as a data science guy, or as a practitioner, or as a business owner, or even a business guy, uh, all customer data is, I think, highly valuable for you as a business, and two, highly valuable for the user as well, right? And it's extremely important that we manage this with a lot of sensitivity, and ensure that we protect it with whatever means and mechanisms that we can put around accessing this data. Now, why have I called out risk and governance here? Because one very key aspect of data science, or any data science, whether you're doing machine learning, whether you are doing AI, right? I think we tend to look at only outcomes. We tend to forget that the risk and governance piece of it, right? And there is a whole notion around responsible AI, which is going on right now, right? Which sort of helps you eliminate gender biases or eliminate racial biases and so on and so forth. So governance, risk and governance can also be sort of pulled into that pillar and thought through, right? Now, again, so go back to your workplace, or go back to the place that you want to sort of apply for, or where you aspire to be working, right? If you're a young student, and think about take a business and think about, how can I help this business improve revenue, profitability, customer experience, and how do I take care of the risk and governance aspects or around the data that I work with, right? Now, the most important thing here is, I think, is that it is not about tools. It is not about what platform do I use, and so on and so forth. A lot of people look at data science that should I do Python, or should I learn AWS? Should I learn Azure? Should I learn Databricks? So it is very hammer and nail kind of a thought process, right? Like, if I learn, should I learn Scala? I mean, it is just a tool, right? And you can learn it. Of course, I mean, there are many tools, such tools available. There are better tools which are coming up in the market as of now. But I think that approach to thinking about data science is absolutely incorrect, as per my view. I think the best approach to think about data science is look at a business and look at these 4 pillars and think about data science from that aspect. Then it doesn't matter whatever tool you use, right? It doesn't matter what frameworks you use. It doesn't matter which cloud platform or which platform you're on, right? Or you're doing it on premise as well. That doesn't matter. Or you're coding away on your laptop. That doesn't matter. But think about it from this. So this should be the baseline thinking when you look at data science, right? And now, how it will help you individually, right? So if you're a young student, it will let you think of data science from an impact perspective, right? So when you are learning something, or when you are trying to pick up a platform or pick up a framework, or you will sort of not think about the framework. You will just think about the applicability of the framework for a particular business outcome, right? And that also sort of filters it down, or funnels it in terms of how you start learning about things, right? So one is learning about Python, just knowing syntaxes or knowing logic, that's fine. But learning Python with the intent of getting a XYZ business outcome is going to be far more fruitful for you, because now you will know what you're learning and how you're applying it, right? So it's not just about learning, it's also about the application part of it. And hence there are I think, if you read the McKinsey articles, or if you read any of these business publications, they'll tell you data science has 5,000 metrics. There are 5,000 things that you can do, and I have another slide coming up which talks about these things. But there are 5,000 metrics that we need to calculate and other things, right? But yeah, then maybe that's fine. Just filter it down to four simple thoughts, right? Like, are these metrics going to help me increase one of these three pillars, right? So that is how you sort of funnel it. And now if you think from this perspective, you will suddenly start solving, or your own personal challenge of figuring out where I want to go from a data as a data scientist, or from a data science perspective, right? So it sort of becomes a very simple mental model. We use that mental model to sort of figure out what is my learning path, or how do I pick this up, and so on and so forth. Now, the second part of it, so we thought about data science, and we said that, okay, we are going to think about data science in two ways, right? One is business. What is the other part of it? It's the technology part of it. Very simple, right? And folks who are on the call and who aspire, or who are already in data science, and if you want to sort of go up the chain in this, I think you have to be at the intersection of business and technology, right? You can't be only technology. You can't be the best coder of an XYZ framework on the planet, but have no understanding of business, right? So can't happen. You can't be the best business guy, but have no understanding of technology. Cannot happen, right? They are mutually exclusive, and they have to survive with each other. So when you think of technology, I have just very simply filtered it out in two things. And now this is applicable for an organization, right? When you think you are an organization who is looking at how do I do data science in my organization, this is applicable, and it's also applicable to an individual, like the folks who are on the call, right? To think about how do I think about data science as a platform, or data science as a career, right? And this also segues us into why cloud, but I will quickly explain what I mean here, right? So from a technology perspective, if you're in data science, whether you're doing analytics, whether you're doing AI, whether you're doing machine learning, right? What happens is that when you're doing all of, say you're working on any specific problem statement, right? So for a fraud, for example, right? So what happens is that, you typically, people start looking at fraud from their transactions perspective. They say, okay, this is a ledger of my transactions, help me find fraud. But fraud can also be thought through from multiple different areas or multiple different angles, right? So it's not about just the transactions that I have while I think about doing trying to reduce fraud or lower fraud. It is also about the interactions, right? Like, so just the transactions, I can also add geospatial location for it. Very simple, right? I know that for all these transactions for an XYZ user, say Raksha, right? Like when Raksha is doing transactions, all her transactions happen typically out of Bangalore, right? So when Raksha out of the blue does 3 transactions from Bangalore and the 4th transaction happens from, say, Australia, right? It is a no-brainer that there's something wrong in this, right? So we think, and so hence we have to think about as data science or data analytics as an individual. You will have to start thinking about it from what additional data. So if I'm building a machine learning model, what additional data points can help me sort of curate this model better, right? Which will give me far more actionable insight, and you will be surprised to find out that there are data points which you wouldn't have even thought of. I'll give you another simple example. If you have a Uber, right? If you ever use Uber, 2 people standing at the same point, right? Book an Uber for the same location, destination. The first person will have 100% battery. The second person will have 20% battery, right? And you check the fares. Just right. You will see that the person with 20% battery may probably get a little higher fare compared to the first person who has a full battery. Why so? Because Uber, obviously, as an app, would sort of track your phone battery status and seeing that it is at 20%, know that you would be ready to pay a little more premium to get home quickly or get to wherever you are quickly, right? So it's just very small, simple ideas, right? Which battery data wouldn't have been my first choice if I would be thinking logically, right? When I wanted to do my fare calculation, but I would, right? And there are a host of other factors as well, right? The number of times you have sort of accepted a premium fare, number of times you accepted a surge and you went, right? It shows that you don't really care about the money, but you really need to get from A to B, right? And that you start saying that you will get higher fares more frequently, right? So that's another way to think of data, right? And that's what I said. So the idea is but to get all of this data, all of this siloed data, right? Phone parameters or your usage patterns and so on and so forth, right? In the case of Uber, you get all of this together in one single source, and that one single source becomes your sort of the version of truth that you can sort of use to now start thinking about data science and so on and so forth. The second part, I think partially I also covered, right? External data or unstructured data, right? So you don't just take your transaction data, you also take your interaction data and it's sort of merged together and try and figure out how you can sort of add more value to any data science project that you're working on. Now, while this is applicable to an organization who would say, I want to collect more data about my users, I want web stream, click stream, so on and so forth, right? I want social media data, right? I want camera data, IoT data, so on and so forth. But as a user, I think it is, and this is it will be one feature that will differentiate you, right? Or as a data science aspirant or business guy, it will differentiate you in terms of how you think about things, right? So you have to start thinking about data points which are over and above, rather than just going and saying, okay, I want to do linear regression on X set of data available, right? And you might just say, okay, I'll do this, but let me think about what other data I can sort of capture, right? Outside, a lot of data is available freely. There are a lot of data APIs available, which you can sort of get into, mash with your data and build a better model. The third part is platform, not tools, right? So, and I sort of alluded to this a little earlier in terms of thinking as an individual, right? Or as an aspirant in the space. Now, when I say platform, I mean, you always think about data science or data analytics as a platform, right? And when I say platform, I don't mean that, oh, think about it as a Azure, think about it as an AWS. I'm saying, think about it as what are the building blocks that you need, right, to sort of get into this space, and what areas within these building blocks you want to sort of excel in, or learn more about, right? So because when you do a data science, when you are say you're writing a machine learning model for, say, churn analytics, right? It is not about just getting the data, like somebody is going to hand over the data to you and you write the model. You will, as an aspirant, you will have to think about it from where is this data coming from, the source, all the way to how do I ingest it to my platform, wherever I'm planning to do this. It can be your laptop, it can be a cloud system, it can be anything. And then from there, how do I analyze it, right? What are the frameworks I need to use to analyze it? And then how do I serve this data, right? And how do I make it easier for a business to sort of understand this data? So you have to think of it from end to end. And the most critical part, especially in data science projects, is the ops part of it, right? Whether it's the DevOps or whether it is ML ops, the ops part of it is sort of very critical. And I think a lot of people absolutely ignore and miss this space, right? ML ops is, I think, the biggest detrimental, or biggest factor which is slowing down this space because of just poor operation planning around your pipelines and other things. So that is one area. Hence, think of it from a platform perspective, right? Whether it's your career or whether it's a project, whether it is your organization, think of it as a platform perspective, right? How do I go from A to B, and how do I excel in A, B, C, D areas? I think I've taken more time than I expected, but yeah. But I would say that once you think about it from a platform, with a platform view, you would sort of be a far more or better prepared to sort of handle these things, right? So, and simple way to see about platform is I say ingestion, I will use Kafka, so I would know Kafka. So ML ops, I will use some ML ops tool, right? Whether it is a cloud native tool, whether it's a external tool that I can get from the market, and so on and so forth. And then from a processing perspective, I will use a data warehouse, I will use a machine learning cluster, I will use a GPU, so on and so forth. So if you think about it that way, and then when I use the GPU, what framework I'm going to do it, right? Like whether I'm going to use TensorFlow, scikit-learn, so on and so forth. And then how do I serve this data, right? Am I going to use a visualization tool? Am I going to just maybe use some Power BI or a ClickView or TabView or whatever, right? Like, so each of these individual elements are important. So as you progress in your journey from your own career perspective, pick up these battles and sort of individually solve them for yourself, right? A good data scientist is somebody who can do this end to end and not just write code and fix this, right? So that is another way of thinking. The last point is more around uh, using tools, and this is more important from a cloud native perspective, that a lot of times we tend to uh, think of transactions or system of records, right, our databases, etc., as the system of analytics. So we write brilliant queries on top of it and sort of do it. But coming back to the top 3 points, this sort of comes in together here, right? So when you think about data science, look at it from platforms or systems which can do massively parallel or scale out models, because as your data grows, you will need more scaling out, and as your data grows, you need more scaling out for training, for learning, for developing, and then deployments also. So you have to think about it from that perspective, and that's where sort of cloud becomes extremely viable for its agility, for its low cost, right? The cost of storing a terabyte of data in cloud is just about $20 now. So which is extremely cheap now, right? So that means when I talk about the earlier points, like get more data for a specific use case, you can do that freely without worrying about the costs involved around it, right? And cloud also gives you these storage systems, right, like blob storages or object stores, right, which, so an S3 or a Azure, a data lake in Azure, or an S3 in AWS, which sort of lets you create this single source of truth, or single source of single version of data in them at a very low cost. And then all open source platforms available on cloud, right, whether it is Spark, whether it is Python, whether it is SQL or Spark or whatever, right? Like, so all of these are available. Hadoop-based systems, etc., are available on a pay-as-you-go, or use as you need kind of a model. So that becomes very easy, right? So just recapping this, basically two ways to think about your career, two ways to think about your the projects that you're working on or your organization. One is business, one is technology. From a business perspective, just think about top line, bottom line, customer experience, and all the risk and governance that you need to do because you're working with data. And from a technology perspective, build scalable, agile systems, right? Which can sort of think about it as platforms. Don't think about individual tools. Don't be too focused on, I want to sort of be an expert in one tool alone, right? Because cloud is an ever growing field, open source is an ever growing field. Every day you see something new come up in the market, and sort of that lets you sort of play with data in very different ways, right? So while machine learning, AI has been very popular, graph databases have become really popular right now, for example, right? And they let you sort of visualize or imagine data in a very different way, right? Like imagine data from a connections perspective, right? How are my customers connected? How are my suppliers connected? How are my customers connected to my suppliers? So on and so forth. So a lot of new technology will be coming in. Hence, you should have a little more platform view, and then you can pick up specific tools that you see in the market that that you feel are important. You can do. You can pick up those and sort of master them. And all of these cloud platforms for any student or any organizer, most of them are available for, like, the initial startup or the initial getting on is there are a lot of these free credits when you get started off. They have brilliant tutorials available within those specific services, and you can run those tutorials at no cost to you, especially for students, right? Like if you're learning machine learning, I mean, don't just understand the concepts, go and write something around it, right? So you can use the free tiers, etc., to build these models or practice this. And whenever you do, think about it from what technology applies to what sort of a business benefit to me, right? So I think while speaking, I covered a lot of these use cases, right? But if you see again, another what I've again done is, every business has this, right? I'm sure everyone agrees with me. Every business has a marketing, sales, service, finance, operations, and workforce, right? So think about use cases from these perspectives. So if I'm marketing, think about how do I do better product recommendation to my customer, right? And we spoke about this, right? So a payment app can sort of recommend say a specific vendor or a new service to them, because they understand from data that this specific user is now is using this app for an X purpose and recommend, say, other service providers in that. Right? Customer insights, again, we spoke about it. Churn analytics, what, say somebody has not used something for like 3, 4, 5 days, pop in an offer. You typically see that, right? Like, so if you've not used an e-commerce app for a long time, suddenly they'll come a pop-up that, okay, we are giving you 5% off, it's been a long time we've seen you. So, all this is part of churn analytics, right? The propensity for a customer to go away from it, right? Again, sales can be something like lead scoring or understanding sales insights, right? Like, seller data, understanding it. How do I price certain things, like dynamic pricing we spoke about from an Uber perspective, right? So how do I smartly price my product and services so that I can have the best revenue out of it? Again, services, you've seen there's a wave of chatbots. Everything and everyone is a chatbot right now, right? Like, so chatbots have been sort of being used. Again, in services, there is a lot of voice bots now, right? So voice bots used for first call response. So instead of waiting online and waiting for somebody to pick up the phone and talk to you, they would say that, okay, what they would have a bot sort of interacting with you. What is your problem? We'll take this down, we'll take this data, so on and so forth. And when it is absolutely unsolvable, a very tricky situation, it would sort of push it back to an agent. But it's a very simple thing, they would sort of address it with the bot itself, right? And that is a really smart way in terms of doing better profitability. Again, finance, I mean, it's fairly self-explanatory, understanding how my business can get better cash flow, or what is the trend for my business, and so on and so forth, right? And as a user, or as a student, or as a business owner, I'm sure somewhere down the line you think about it. And if you're practicing, trying to learn, or doing use cases, or trying to build some projects around it, think about it from this perspective. Operations, again, IoT has been absolutely pervasive in this industry, and especially in the manufacturing industry. We're seeing the entire manufacturing line being full of sensors, so that we can track a lot, and that is also a part of customer experience, right? Like, so quality tracking and so on and so forth can happen via IoT devices. And then again, as a workforce, right, as an organization, we think about it from insights, like, how do I understand my employees better, or how can I help my HR get better view on my employee data, and so on and so forth, right? How do I plan better in terms of hiring, and so on and so forth. So these are typically, the use cases that you would see. There are thousands more, but since I have given you this hack, you use this hack to figure out more use cases while you do your projects, or you apply it within your organization, or you apply it within any project that you're working on, right? So use this hack of simplifying and business understanding, and try and figure out more such use cases. I think I'll take a pause now. I'm sorry I took 45 minutes, but I hope it was useful. I think, Raksha, we can move to the Q&A. I'll also try and open up the chat.
Some questions are posted in Q&A as well. You can pick it from here.
Sorry?
Sir, some questions are posted in Q&A section, so we can pick some questions. Please.
Okay, I can pick this. I can pick it on my. Okay, so I think, let me check about 15 questions, right? I think we can go through it very quickly. Try and see. So I think there's a question in terms of online degree, Master of Data Science can make me eligible for applying campus PhD in data science online degree. See, yeah, so I mean, there is no guarantee to it, but I think any online degree, I mean, I'm a big fan of online degrees, and this is my personal opinion. Again, don't take it as career advice, but I'm a big fan of online degrees, because I feel I'm not just online. I mean, the Coursera certifications, the edX certifications, the Harvard certifications, right? I'm a big fan, because what happens is that you sort of get a taste of, or you have more skin in the game before you actually sort of commit to something large, right? So I know a couple of folks who are going into data science just because it is the hot word right now, right? Everybody is talking about data science. I want to get into data science, and my advice to him was that, and it's a young kid, right? Like, so I said, do one thing, go to Coursera, find a data science course, do it, right? The free certification, right? Whatever. If you want to pay for it, that's fine. But do it and see at the end of the course, are you really interested in this or not? Like he came back and said, no, I mean, something that I didn't enjoy, right? And this is not my cup of tea. I need to rethink in terms of what I want to do, right? So that these are, I think, no online degree is a guarantee, but it shows two things. One, that you are learning and you are curious. Two, it gives you a level up in terms of when you apply for any PhD course or etc. It gives you level up because you are not starting from scratch, or you've already done XY things before you come on, before you get in, right? And while you're doing any online degree and all, go back to the hack. Right? Think about, take a use case, take a customer, take a company that you like, and figure out what analytics can an XYZ company do to do a better, top line, bottom line, customer experience, so and so, right? So I hope that answers your question. So what is the difference between data science, data analyst, and data engineer? Yeah, they are nice labels. I think the way, I mean, you think about it, it should not be by labeling yourself, but the fundamental difference for a data engineer sort of is the one who creates the entire pipelines, right? Like he creates the data, he creates the entire movement of data from source all the way to the processing layer, storage layer, to the processing layer, and then the visualization. Somebody who can visualize the path, right? Data analyst is somebody who then at that processing layer or post processing, he would sort of dig into that data and try and figure out, within that data, how and what can be done, right? Like, what are so take the information and build insights out of it. And a data scientist typically collects the data at a larger scope. Like, so while a data analyst may be working on the last 1 year data and saying that, over the last 1 year, XYZ has happened, or over the last 2 years, something has happened. A data scientist sort of goes back and says, takes a longer view of it, 10 years. What is the trend in that data, right? So yeah, and he tries to, and mostly data scientists get into machine learning and they use AI or neural networks or so on and so forth to sort of figure out what is this data trying to tell us, right? Over a period of time, what is the trend, right? I hope that answers your question. PhD in data science helpful? I think we mostly spoke. 1 second. What are the extra benefits to an analyst who is good at programming, statistics, to learn ML algorithms? A beginner who doesn't know any, what are the top 3 ML algorithms to, yeah, again, see, I think this is what I was telling you earlier, right? And that's why I've made this model. Don't focus on what are the top 3 ML algorithms. Focus on what are the top 3 problems, right? And how do I solve this problem using what algorithm? So then learning that algorithm will become easier for you, right? So take a business problem and think about what ML algorithm can help me solve this problem, right? So don't do it reverse. Don't learn all the algorithms and say, now where do I apply it? It can't be done that way, right? Think about a problem, go back, learn that algorithm. Think about a problem, go back, learn that algorithm. So you'll find there are, there are about 17, 18 odd typical algorithms available. So if you can think about 100 problems, you'll find about 17, 18 odd models will sort of solve those 100 problems by default. So think about problems first, solve them using this. Don't go the other way, right? What are the extra benefits to an analyst programming? And see, I think most analysts would definitely benefit, because while earlier it was more thought through as a manual, people would dig into data, write queries, think about, create slices and dices of data and try and figure out answers. A lot of this is becoming automated now, right? Like fraud, for example, right? Earlier people would write queries and figure out what are the frauds. But now fraud can be sort of detected real time because somebody has written an algorithm which sort of answers that specific problem statement upfront, right? So I think there are no benefits. That is the future. That is the future. There's no extra benefits. It is the future for an analyst to possibly get into this space. There are 2 ways that will happen. One is obviously you can be a data scientist and sort of apply your knowledge to the data. The other is, as I was saying, citizen data scientist, right? You may be a business owner, right? You may be running a business, or you may be head of sales or something. And now what has happened is a lot of, especially in the cloud, there is ML in ML, right? So there is automated learning, for example, in Azure. Even AWS has something called SageMaker, which does the prediction by itself. So so you don't really need to think about what algorithm to apply. What it does, it runs all these algorithms on the data and says that, the best fit is, this is 97% applicable, this is 40% applicable, 80% applicable, so on and so forth. So think about it from that perspective. Where do we get business problems which we could attempt to solve using? Oh, you just Google this once and try it. I mean, it's, I mean, you can just, I mean, this is something you can Google. What do you mean by ML ops? Okay. One starts to one avenue platform cloud technology that one needs to learn to be relevant to be applied. Good. I think this is a good question, right? So, and that's what I actually alluded to earlier. So ML ops is actually not about the machine learning part of it. It's about creating that entire, when you get data, right? If you get data, it doesn't, you can't just run a algorithm on top of it, right? There is some level of cleaning, massaging, that you do on that data, and some level of transformations that you will do on the data, right? And change it and get rid of bad data, improve the data quality before you actually feed it to a machine learning system, right? So where a data scientist works on. Now, the in-between part, that entire pipeline, and you can't do this every time you get data, you will not go and do it, right? You will sort of build a automated pipeline saying that whenever data comes, this pipeline gets triggered, right? And it does A, B, C, D, and then the data gets fed into my processing system or machine learning system. So this is typically this entire operation of getting the data right from source to get till the processing of the data starts, right? And how it should be processed, where it should be processed, how long it should be processed, what data sets you should take. So this entire orchestration of this is called ML ops, right? When you do it for machine learning, it is called ML ops. If you're building applications, it's called DevOps, so on and so forth. And so this is something I think where you can learn it out. I mean, you are on the perfect platform. Analytics Vidhya has I mean, I'm a mentor in their data science course, so that's where we actually I think these guys teach it. I mean, focus a lot on the MLOps piece and give a lot of information around how to do it. This one avenue platform cloud, I think to be very honest, there's no such one avenue platform cloud. All the clouds are more or less the same. It's just a nuance or syntax or some other things, right? Some have better features, some have better cost, so on and so forth. So there's no, I think you can pick a cloud of your choice, start with that, and you will see that the other cloud, right? If you start with Azure, for example, and you learn Azure and you do the Azure certification around it, you will realize that going back to it, if you have to use AWS, it's not going to be that difficult, right? It's just going to be about nuances of how you use use that platform, right? So for example, I mean, very simple analogy is like if you knew how to when Facebook came, you were on Facebook, right? So when Instagram came, you didn't do another PhD to learn Instagram, right? You just figured it out. So I think mostly cloud platforms are similar with some nuances and changes in that, right? Some differentiators. But learning one doesn't mean the other one will be another. You start from scratch. You start somewhere around 70-80%. Sorry. Is it advisable to start data analysis? Your desire is machine learning, because knowing all these tools is just ambiguous for me. Important for a data scientist and machine learning engineer. Okay, yes. Start from data analysis, but yes. So I think Michael has this question, whether it is advisable to start from data analysis, but your desire is machine learning. Yes, I think it is. I think data analysis or machine learning. That's why I didn't put science there, right? Like it's all the same, right? It's just about what you use to figure and how you use to analyze or data to get to to solve a X problem, right? Or to understand an X insight. So you can start from anywhere, to be very honest, right? Eventually, if you, I mean, do machine learning, you need to know the basics of data analysis, right? You need to know so a few, I mean, basics to deal with how to deal with data, or how to say, as I said, right, transforming or all transformations and all that. So you need some basics. So yes, I think start with the basics, build it pillar by pillar, and then maybe progress to machine learning after that. That would make better sense. How to learn to get insights? We just learn through charts, little manipulation. What is your unique way of thinking? Data is completely numerical or alien without any dictionary. I honestly didn't understand this question, so I'm going to skip it. There is data engineer in this process. Okay, data engineer is where is data engineer in the process? So data engineer sort of builds all of this, right? Like, so he is the guy who would come in and say that, uh, this data I will sort of clean, or I will remove. Say if you're getting a data set with like say 100 columns, and the data engineer would say that I will sort of configure this in a way that, when I get the data of 100 columns, but my user only needs say 50 columns. So I will configure it in terms of, we'll get the data to the storage, we will process it once and create a version 2 of the data. In that processing, I will eliminate this, and then I will feed the data to my processing system. So if that in the data engineer sort of creates that entire workflow pipeline, right? So he would write a code in sort of maybe, eliminating data sets, or maybe transforming data sets, transposing data sets, so on and so forth. So data engineer comes in, he's the guy who sort of builds the entire plumbing for the data to move from X to Y. What tools are primarily used for MLOps? Okay, that's a good question. So all native cloud platforms have their own MLOps tools, right? They're native. You use, so as I said, AWS has SageMaker, Azure has Azure AML, machine learning, right? So they have their native MLOps tool. Now there are a lot of external MLOps tools also available outside the box, right? So DataRobot is one, DataIQ is one. There is another thing called Spark Beyond. So there are such a few more of these which are available outside also. And then the idea is to understand MLOps at a fundamental level. So you can use something like the native tools because they are free. Most MLOps tools are free within the native cloud platform. The additional ones, so like, as I said, DataIQ or something like that, they would be additional costs, right? Like, so you may start learning this or understanding it from the native tools initially, and then sort of figure out how you can look at the other tools. There is no, I mean, MLOps is more about understanding the process. It is more about understanding how I deal with the next data and how do I make it more usable, consumable, or deployable, right? Like, or trainable. So I think that is the sort of the entire pipeline or the workflow is something that you need to focus on. What are the main challenges of applying AI in the real world of business? I would say I think one of the key challenges is data quality, getting quality data available, right? Like, so that is one key challenge. I think the other challenges are more around resources and talent, to be very honest. I mean, while we say that we are a young country, country with a younger demographic, but we don't have the right talent to sort of, apply all these use cases in the real world. So, and that's where we see that, there's a massive demand, at least in India itself, within India, right? Internal consumption, there's massive demand for data science guys, massive demand for data engineering guys and data analysts, etc. Mm. Is hackathon is better to prepare for data science job? Yes, I think I don't know what you mean by hackathon, but I would say a real hands-on practice. I mean, if that is what you meant, hands-on practice is definitely a much better idea because it sort of gives you a better understanding of not just conceptually but also what I mean, how from an application perspective. So it lets you apply what you learned as a data scientist. It lets you understand your thought process is better. So yes, when you say hackathon, I mean real. And I told you this also, right? Like, you go to Azure. For there's one more question. Please tell one real-time example of data science used in business, right? So if you go to Azure and you open the portal and you go to machine learning, you'll find there is a small learn while you code kind of a tutorial available. right? So it's also one of them, I believe, as something I did. I think I did it about 3-4 years ago. But something I did was around Twitter sentiment analytics, right? So there was a data of Twitter data on sentiment, and then basically how to clean the data, apply apply a more classification model on it, and so on and so forth. So this is available natively in the cloud, and then you can go to thousand. There's Kaggle, and there are a lot of these use cases available on multiple websites, right? So, and with data, so if you go to GitHub, you will find some sample code, sample data sets to work upon. So GitHub has it, Kaggle has it. So there are data is available in dime a dozen, right? So you can use that. I think 1 second, let me see more.
Okay, so sorry to interrupt.
Sure.
So I guess before we take a few more questions, before that, I would like to request all the attendees to please share in the feedback poll. I'm sharing it here.
Sure. Okay. Am I good to go, Raksha?
Yes, sir. I guess, can you please give me 2 minutes for
Sure.
feedback poll? We will be conducting that.
Yes.
After that, we can continue.
I think we are over time already, right?
Yes.
Yeah. So I think we'll do another 5 minutes and and give them time to sort of.
Yes, exactly. Sir.
Uh,
So here is the feedback poll.
sure.
Please participate, everyone.
Cool. Okay, there's a question here which says, please explain why the need for developing complex ML pipelines on local machines when there are platforms that can handle these, and if those, why do we need to go and other server codes? Yeah, I mean, this question is from Murufu, and it's a very valid point that he said. So he basically, his question is that, why do we need to develop complex ML pipelines on local machines when they are platforms that can help? So that's exactly what I said, right? So MLOps, all the cloud service providers have native tools for MLOps, right? And the those platforms are really good. And then you have some products as well, right? Like some new organizations which have come in, which are making it even more easier to do MLOps, right? So honestly, why do we need to bother about MLOps and pipelines? Because I think it is about getting it right the first time, like getting these pipelines right. Uh, you might be thinking about it from one pipeline or two pipeline, but if you go into an organization, say a typical bank has about, at any point in time, about 400-500 pipelines, 400-500 pipelines any point in time running daily. Now, if you have not built, uh, if you've not thought through your MLOps strategy in advance, what is going to happen is managing, maintaining, sustaining this entire IT project or the entire analytics project is going to become a nightmare going down the line, right? And now, don't just think about it from one perspective of technical management and maintenance. Also think about attrition, right? So somebody moves out of the organization, a new person comes in, and there are 600 pipelines that he sees. How is he supposed to get a sense of what is happening there, right? So good pipelines with good documentation, etc., are very important. So I think MLOps is absolutely critical and a very underrated or under focused kind of activity within machine learning. So that's why we get questions, and what few of the questions here were those, right? Around what should I learn, what should I learn around this and all that. Which platform should I, which platform, which framework, which algorithm. Don't worry about it. Take a problem, figure out what algorithm or what framework and what platform suits you the best, solve it there, right? And move on. And so then you will not only learn the algorithm, you will learn how to apply the algorithm in a specific use case and think bigger around it. Now, if you've done it for a specific use case, what is the additional data that I can get and add to what I have? and then apply the algorithm again, right? And how does my data set change, right? Or how does my output change? So these things are very critical. So I think that sort of, I hope that answered your question. Slides, your problem. DevOps tools like Jenkins, Docker. So, okay, does any DevOps tools like Jenkins, Dockers play any role in ML ops? Not really, to be very honest. ML ops is a little more sort of nuanced, to be very honest. So that's why you will see very specific tools come in for ML ops, right? So, and Jenkins, etc., are used, Dockers are used to deploy a model at the end, at the endpoints, but not during this. So MLOps also covers the fact that, after you've trained a model or something, you can also deploy it at the endpoint. So it covers it from end to end. What are your insights on explainable AI? I think it's a game changer. And I have seen personally some brilliant development around explainable AI, especially in Azure as well. And I think it's going to be a game changer, and it's going to be a game changer. And I somewhere had read a question on responsible AI also, but it's going to be a game changer because it is going to make your models far more cleaner and give it far more integrity, right? So it will because I think while we say it is artificial intelligence, it still lacks that real intelligence, right? So we see, and we've seen that happen in many cases where there is a lot of bias being brought into the data, and bias is not important. The bias was a problematic. It was problematic because not because of the accuracy of it. It actually sort of discriminated. The data would discriminate a certain set of people or a certain gender or certain. So I think that is a very, that is something that AI, and it is our duty to sort of ensure that that doesn't happen when we run these models, or when we run these machine learning models, right? So it is so explainable AI is going to be the game changer because it is going to bring in that integrity to the model. It is going to explain all the parameters that went into doing this, and absolute game changer. And I think one tip for all of you guys, and do take time out, and I think you can, I know Azure and Satya speaks about responsible AI quite a lot. So I think you should go and check out the responsible AI. We have a complete narrative around responsible AI on the Azure webpage. So you should go and check it out. I think even AWS has it. So I think you should read about that before. While you're doing your projects, or because it's absolutely critical that we have models which are very high integrity. Shall we go for management console or CLI for cloud? Okay, so especially if you've seen, I'm not sure if you've used these, but uh, business folks, right? Business folks, not data scientists, but business folks who are thinking about data science. Your life has become very easy, right? Even the young students, life has become very easy. So there are a lot of designer like tools available for free, right? You will not charge for using designers. So designer tools are available natively. Azure has its own designer, and they're very simple, right? Like, if you know the logic, like this is how it should go, drag and drop your logic, write your code within that, and deploy. So I think CLI is great for people who like to type, but I think that is something which has been very smartly abstracted by cloud, right? And a lot of cloud companies have come in. Even these MLOps tools, which I was talking about, DataIQ or DataRobot, they have also done the same thing. They've made it very simple for a person who understands business, not necessarily a data scientist, right? Citizen data scientist. I understand my business. I know I have this data. I'm going to pull this data into, say, maybe whatever cloud I'm using, Azure cloud maybe, and then sort of build my logic around it. And the logics are available, like linear regression, out of the box available, drag, drop linear regression, make some changes to the parameters, right? And do it. So that is one part of it. So management consoles have become far more savvier and far more easier for business guys also to use it. And I mean, it's a no-brainer. And then I think I already spoke about it. There is automated ML, etc., which sort of runs a model on top of your data beforehand, before you actually start any ML work, and tells you what is the probability of accuracy and so on and so forth, right? Scores your data, gives you scores for the different algorithms that can be run on the data, and it sort of helps you get started at 40-50% rather than 10%, and do it right. Hyperparameter optimization is available in most of the clouds, right? And that again, sort of as a data scientist, helps you reduce the manual work that you would require to do in terms of working with data. So I think when I think the question was on management console or CLI, it is, I think, no-brainer management console, unless you have preference to CLI, but it's absolutely an individual's choice. But I think there are a lot of, it has gone beyond that, and there are a lot of other tools available with natively within cloud systems which you can use. Yeah. Okay. I think we are 10 minutes overdue, Raksha. So I think I'll take a pause here.
Yes, I think either most of the questions are covered or they are repetitive, and we are already running short on time. So we can wrap up the session here. Thanks a lot, Sachin sir, on behalf of Analytics Vidhya. I would like to thank you for devoting your time and delivering such a wonderful session. I'm sure our audience found it insightful, and hopefully we can conduct more such sessions with you in the future.
Likewise, Raksha, thanks to Analytics Vidhya for giving me this opportunity. It was great interacting with you. I mean, some really good questions there, and I hope this was helpful for all of you.
Yes, and for the attendees also, I would like to request to check out our platform, Analytics Vidhya. You can find many useful resources or content to kickstart your journey in this data science session. So I would like to request everyone to please share your feedback in this poll. It would help us to conduct such more sessions. And we will be back with another session of the Data Hour on 25th July, which is Bias and Fairness in NLP. So link is in the chat section. Till then, bye-bye and keep learning, everyone. Thank you so much, sir. We will wrap up the session here.
Sure. Thank you.
Welcome.